Welcome back to Pop Goes the Stack, where we take the comforting myths of old school performance engineering, hold them up to the light of modern AI systems, and watch them crumble like day old biscotti. I'm your host, Lori MacVittie, and as almost always, our co host, Joel Hope Moses, is here to help keep us on track.
Hey, Lori, good to be here.
Good to be here. You didn't have a choice. We made
No,
you. We,
no.
yeah.
I was shanghaied, definitely.
Yes, it's horrible, huh? Well, once upon a time, performance meant deterministic response times, right? We
Oh, yeah,
measure performance. We have to because we have to care about it because users are impatient. We don't like to wait. But back in the old days, I like that. We're already in the old days, right? Identical input, identical execution paths, identical
right.
latency. Universe was nice, orderly. Engineers slept well at night, and nobody had to ask what token variance meant. They didn't. They didn't care. But inferences showed up, and it's rewriting the entire rule book in crayons. We got no idea. Performance is probabilistic, latency is wiggling, not jittering, wiggling
Wiggling.
now. Throughput swerving. Identical requests walk through different kinds of pipelines and come out wherever the heck they want.
Yeah,
So today's episode is really about that shift. Last episode, we talked about availability and how the definition of that is changing and how we have to change measures. And this time, we want to focus on performance because that too is being impacted. And to talk about performance, we brought somebody on who's really well versed in all things performance. Nina, welcome.
I'm so glad to be here. Thanks for the invite.
Yeah.
Yeah, I guess a little bit of background. I used to do all the performance testing at F5 for quite a few years. So
Yes.
uh,
Yeah, that's when
yeah,
I hear performance and figuring out numbers, I'm like, it's got to be Nina because she knows she's done all sorts of different kinds of
yeah.
performance testing, apps, our products, everything. So she's got a good view on performance and is now working with a lot of the AI systems. So more, right, about performance. So, I mean, let's dig in. So, performance is not what it used to be, right? We're
yeah, I mean, it used
No,
to just be about throughput and connections per second, and it's changed now. That how 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 fast you get the response back is not the only thing that matters.
that's correct. Yeah, and there's a fair measure, especially in these artificial intelligence applications, of non-deterministic performance, even to the same types or subjects of prompts, right? So you can, it's really fun for me to talk to some of the old school veteran system engineers who are used to, spending 8 milliseconds of compute and getting 8 milliseconds response time out of that. Those were the days, but we're beyond that now. Inference systems, the same prompt can take from 300 milliseconds to 3 seconds. And, it's always tough to talk to folks who are used to the old deterministic ways and the pain in their eyes when they can no longer rely on things to return in predictable time. One of them described it to me as a character building moment when he realized that the old tricks didn't work anymore.
Yeah, yeah.
it's that predictable piece. I mean, one of the things we saw early on with ChatGPT when it first came out is people's tolerance for a lot of latency went way through the roof. Like, as long as it said, "Oh, I'm thinking," right, we reacted in very human ways, like, "Oh, well, let's give it time." Right.
Mhm.
When the same thing for an application, if it wasn't back in the blink of an eye, we'd be throwing our phone across the room and complaining about the internet. I,
And now we're worried about how much it costs, how much
yeah.
that little connection makes. How much is
Yeah.
this question going to cost me?
Yeah, I mean, honestly, a lot of us used to brag about, achieving our best 20 millisecond response times, and now the with AI systems, it's better if you simply brag about your 95th percentile, because no one really cares about how fast your fastest response is. They just care how slow the slowest one is. Especially, and that matters especially if
Mm.
you're the one who got the slowest response, right? But non-deterministic performance, it's more about the perception that the performance is faster than it is. These systems don't respond in deterministic time, and so that's why you have the little three dots that precede the response, and why systems talk about how they're thinking about a response. It's in order to give instantaneous feedback to a user so that they will sit and wait for the tokens to be allocated and finished.
Right. Well, it's also why they stream the response. Those tokens are being generated and it's being streamed back a little bit at a time, but it gives the perception that something is happening and you can only read so fast anyway. So you're seeing it come out even as it's still working in the background, right? It's not
Right.
compute the answer and then send it back. And that's very different when you are maybe the system engineer or the on the operation side and you're trying to figure out like what are my KPIs for this? What am I measuring anymore? Like users yelling at me? Am I regexing for angry words to see if they're, happy or not? How do you deal with that? Because it completely changes everything about how we manage performance.
Yeah. And how
Yeah.
much it costs as well.
It's a,
Yeah. I mean, I think I was
Yeah.
playing around with a chat bot a little while ago and I asked a question. I asked the same question and I got 3 different answers. And I was like, this is not right. So it's like, even that level of performance, like there needs to be guardrails to make
Yeah.
sure that the answers are not only the correct, but can you imagine getting 3 different answers and 3 different costs for the same question?
Oh
That's
yeah.
just changes how you look at applications nowadays.
It does. It also changes how people think about the cost of the application. I once tried to explain tokens per second to our finance team, and I said, think about it like cost per word generated over time. And then they were like, well, wait a minute. Does that mean that when it slows down, we pay more? And I said, yes, that's exactly what it means. And their eyes got so wide, I swear that our GPU budget shrank in real time.
But it's a hard thing to wrap your head around. It was much easier to go, well, bandwidth, bytes per second, right? These are also very measurable things. We know, well, if it's going to return sizes, we could optimize for it. How do you optimize for responses? Are we constantly telling the models behind the user's back, really short answers, one
Mhm.
word, don't go over budget.
Well, I mean, I think when you're working with non-deterministic responses from some of these systems, you try to get determinism into the system as much as possible. So, getting rid of delay in internetworking between GPU hosts has an overall effect in terms of the number of tokens per second that you can process. So, anywhere that you can leverage infrastructure determinism to solve for the non-determinism is good. So all the old school tricks about lower latency networking and putting things closer to data resources, those tricks actually do work in terms of delivering performance back into these non-deterministic systems. But it's one of those things where you can kind of optimize these things almost ad infinitum, almost infinitely. And so you
So
have
the
to.
olden days still matter.
The olden days still matter, right? Exactly. So wherever you can move latency and delay out of the system using infrastructure ways to do that, these systems that perform non-deterministically, they take advantage of the fact that there's no added delay or added latency along the path. And so again, it's still worth thinking about determinism, even if you know that you're not going to get it out of the system of record.
But how do you measure that? I'm gonna keep going back to that. How do we measure performance? I mean, Nina, you've developed like thousands of different types of tests to test different types of performance. So if you had to sit down and test an AI for performance, I mean, what would you start measuring? Where do you start with something
I
like
mean,
that to understand?
you use AI to measure AI. I mean, what you know?
Yeah, that's
Wait,
that's that's
doesn't
certainly
that
an approach.
double the cost? Like I
Yeah, I mean, I think there's some data modeling you could do though. I mean, I think finding the guardrails for your questions, like, back in the day, we would do health monitors. You would, check the response to make sure the response has the things you expect to have respond. And it's another way you could do it. If you ask a sample question that, maybe is on the cheaper side, so you don't cost money, but are the responses what you expect? And are the time responses that you're getting back, what's the variance like? And I think that's a reasonable way to do it with some data scientists. But using AI to check AI is not the worst idea I've had.
That's true. That's true.
But you're still measuring response time, it sounds like. You're still measuring, okay,
Yeah.
how long does it take it to respond? How long does it take it to generate? So almost the time between when it first starts sending tokens to its last token and going, okay, this is a number we can actually measure,
Sure.
and we just can't do fast. Is it always under 5 milliseconds? Because we know it won't be, but we can start looking at, and you brought this up when before we started the conversation, Nina, variance.
Mhm.
Right.
Yep.
Yeah, I think in the end, analysis observability is the key, right? Being able to watch not only your infrastructure and how your infrastructure is performing while delivering the AI application, but the impact that that has on the AI delivery itself. So when you're measuring first token to last token, there's a time. And if you can compare that to the changes in infrastructure that you propose or simulate to make, you can actually reduce the time between the first and last tokens by moving data resources closer to the point of inference, for example. So if you're using RAG, if you're going 5 hops away and you're injecting an additional 500 milliseconds of latency in doing so, it's going to translate into a slower first to last token. And so you can actually make changes, small changes, definitely recommended in this type of workload to infrastructure. And through your monitoring, you can correlate one latency reduction to a token per second latency reduction. It's again, it's still going to be non-deterministic. That's just how these systems are. But you can actually measure a performance a difference there.
And you're
Right.
definitely not going to want to look at the latency averaged across. You want to
No.
see what that variance is, and you want to see the high end.
Exactly. And it also means that when you're observing things, you also have to know what the AI system is doing. Is it making RAG queries? Is it touching another AI agent that's out there in doing its response? So it's not just monitoring the infrastructure that you know about around your application. It's also knowing how the AI system might be interconnected to other things. Latency has as you know, even in AI systems, latency has a magnifying effect. The more latency you inject, the more exponential your performance problems become one system over. And that's just performance engineering 101. It's the measuring points are different, and the way we need to monitor and provide observability for these systems is different, but the challenge is the same.
Well, except that, now if we think about agents, we can't know for sure how many different systems it might be making a call to. With web apps, right? We knew, oh, it calls a database and it calls this other service. There's two or three.
Yeah,
Okay, we can factor that in. This agent might call five, it might call two, it might call 10.
that's correct. Yeah,
So
and
there's a
so
lot of variance there
that's
to,
correct,
yeah.
and so why that's why there's an interest in things like MCP gateways and A to A, which gives you the ability to monitor agent to agent traction transactions. These sorts of things are newly emerging, and they're not necessarily in a lot of the observability systems yet, but it's definitely something to watch for.
That's an interesting thought, is that
Hmm.
multiple pieces of infrastructure might be needed to manage performance, like restricting tool calls, restricting agent calls,
Yeah,
watching and feeding back, instead of having just one system that might be watching for performance and kind of being the source of truth.
yeah,
You're going to have multiple systems that you're going to have to correlate, kind of like a performance sim, right? If you will, right? It's going to grab them all. It's Is that what I'm
Yeah, and I
hearing?
think that you also look at like the size of the engine. So like or size of the LLMs, you might want smaller ones running most of your
that's
questions.
right.
And if you do, analysis over time and find that, your small model's not working as well, then
Hmm.
you can take time in order to help learn that smaller model in order to, improve performance and cost across the board. This is like a multi-factor performance nowadays. It's pretty
Exactly.
complicated.
Yeah, and there are also nerd knobs within those LLMs to turn things like temperature, things like bit size of the compiled model. All of these things are things that you can tweak, and they can lead to changes in the token per second. But they can also reduce accuracy, and so you have to be very careful about making direct changes that affect your performance inside the LLM. That's why it's probably better to look at the infrastructure surrounding it find a model that works the way you like it to work and returns the accuracy you like, and then figure out how to optimize everything that surrounds that model. Tweaking the model itself can lead to strange behavior.
That's also, you could, I mean, that would be, is cost a new DDoS, right? I mean, and being able, I'm going to change the temperature and give it this complex question so that it gives me a lot of tokens coming back. Like, can you, like, it's another concern you have about, right? You got to watch performance in terms of that, because it directly relates to cost now in a way that, I mean, bandwidth is cheap, right? We all know that now. So we don't worry about how much does it cost for every, byte I send out, but we are focused on that with tokens because that is the cost model. So we have to be more careful about that.
Yeah.
It's definitely related. That's a lot of change. That's what I'm hearing, is a lot of change. It's not just that if the definition of performance change, if we have to watch variability instead, if we have to watch time between tokens and not bytes, that means that there's a lot of infrastructure changes that have to be made in order to measure it correctly in the first place before you can even start optimizing. Because if you don't know how it's performing, you can't do anything to change it, right?
Yeah,
and you might say, like,
that's true.
Accuracy might not even matter if the results are not correct. So if you're not managing that, then does any of it really like matter? Like it's so dimensional now. It's really hard to figure out.
Yeah, that's actually, Lori, what I'm taking away from this discussion today. There is definitely a new definition for performance within AI-driven applications. I think we used to think about performance like a stopwatch. It's precise, it's predictable. And now it's like a toddler getting ready for bed. Sometimes they respond to you right away. Other times they take 20 minutes. And sometimes they just start telling you a story about a dinosaur for no reason whatsoever. Inference performance is not really about speed. It's about managing variance or variability. It's not how fast is it. It's what mood is it in today, and is it at least coming back in a predictable amount of time, right? It's about maintaining a stable distance between first and last token, and not having some that are way out to lunch and others that return extremely quickly. The variability is actually the new measure of performance.
So, like, if you were enterprise right now, very little AI experience, but you have this problem, what would be the first thing you'd focus on? I think it would be the infrastructure side of figuring out how infrastructure is behaving and then move on up the stack.
Yeah, I think that's a good place to start for sure.
Oh, absolutely. I think there's a lot of different pieces of infrastructure, like I said, that get touched by this, that you have to start looking at. How are we going to measure it? Observability. And all of these things are it's not just multivariable, as you mentioned, Nina. It's also that it's multi-measurement, right? The impact is also, right, it's just expanded because performance could be indicative of a security problem, right? An attack. It could be indicative of a problem in somewhere else in the infrastructure. It's so interrelated with all of these different systems, just the way AI operates, that you have to worry about, okay, I have to know what I'm going to measure, and then I have to start looking at all the other systems that might touch. It is performance. It might be touching, data stores, but it might be a security thing we have to worry about. And really, maybe this is the thing that breaks silos, because everybody has, I can dream. Stop laughing at me. I feel bad now. No silo. Okay, there'll still be silos. There'll be new silos. Um, but there shouldn't, because it really is that related, right? Performance could be a security issue. It could be a cost issue. It could be a infrastructure issue. It could just be a network issue. And we really have to figure out how to get the right measurements to the right systems and the right people in order to figure it out fast, because it costs money, a lot of money. Big
I think everyone, I mean, if you talk about silos, everyone wants to talk to the data team. So at least we have that silo broken down. Like, I think our own AI data team has been very busy, and they're talking to more people than they had ever imagined. So I imagine that's sort of helping silos in some way.
That's right.
That's true. That's true. Well, hey, break. You got to start somewhere, right? One at a
Yeah.
time works. Works. All right. Well, hey, I think that's a wrap for Pop Goes the Stack this week. We can't go back to deterministic compute. That ship has sailed, caught fire, and it's now generating tokens about its feelings as it sinks. But we can and will move on as AI eats your data center. So be sure to subscribe so you know when its next stack time is scheduled.